All right, so here's an example, and this is straight from the exercises. So you'll get a few like this. But basically, what we're trying to do is we're given a point, and we're basically trying to figure out, okay, well, what's this other point, and then let's find the slope, the slope of the secant line. So that's what this m sec means, m secant, and so that's the slope of the secant line, and we're given the function right here, f of x squared plus 1. Okay. So basically, we're just completing this table. So like if I want to find y, all I need to do is just plug x into this function here. Okay. So remember that y equals f of x. And so in the case of part A, y is going to equal f of 1.1, right? And what we can do with that, I'll just write right here since I have a little space. So I'm going to do f of 1.1, and that means I'm putting 1.1 in for x. So it's going to be 1.1 squared plus 1. So I do this on my calculator, right? And that becomes 1.21. So it's 1.21 plus 1, which is 2.21. Okay. So that's what the y coordinate is. So qxy is going to be 1.1 for the x and 2.21 for the y. Okay. Now, if I want to find the slope of the secant line, then all I need to do is just y2 minus y1. So we'll use we have this point already given, right? So we'll use these as our x2, y2, and we'll use these as our x1, y1, right? Remember, these work with any points, but so let's see, or this formula works with any points, I should say. So it's going to be basically y2 minus y1 over x2 minus x1, right? You could also think of it as f of x minus f of a over x minus a, if you want to think of it that way, okay? So this would be x and f of x, and this would be a and f, and this would be f of a, okay? All right, anyway, so I'm going to plug this into the formula, so it's going to be 2.21 minus 2 over 1.1 minus 1, okay? So all it is this minus this, right? That's how I got this on top, and then on the bottom I did this minus this, right? All right, so then we just do the math here. So 2.21 minus 2 is going to be 0.21 or 0.21. 1.1 minus 1 is 0.1. And so 2.1 over 0.1 is going to be 2.1. So 0.21 over 0.1 is 2.1. All right, so that's the slope of the secant line here. Okay, and then we can keep going down the list and keep finding these, right? I'm going to let you do this one here. So what I want you to do is plug that into this function and find b, okay? All right, I got 2.0201, right? So I basically squared 1.01, and then I added 1 to it, right? So that's what the function says to do. So now I have those values, so now we have q. So q is all right, so that's our new coordinate point. Oh, I'm sorry, I messed up here. All right, sorry about that. Yeah, the x coordinate should be 1.01, and the y coordinate should be 2.0201. All right, so now that we're here, now we can use our slope formula. So I'm going to do, I'm still going to use this as my x1, y1, and then this will be my x2, y2. So it'll be 2.0201 on top minus regular 2, right? and then on the bottom it's 1.01 minus 1. So it becomes 0.0201 over 0.01, right? And so what that'll turn into is 2.01. All right. What do you think the next one's going to be? So the next one, if I plug this in for x right here, then what I'll get is when I add 1, I'll get 2.002001, right? So kind of see a pattern from this to this to this. Just kind of adding another 0 there between the 2's and the 2 and the 1. And so this point is going to be 1.001 and then 2.002001. All right, and just cut into the chase here. Let me just, if we plug this into the formula, what we're going to get is 2.001. Okay, and you might be able to see a pattern here. 2.1, 2.01, 2.001. So what do you think this one's going to be? And that's right, 2.0001, right? This will be, let's see, 2.00020001, right? And then we can put that in here, put the x coordinate, y coordinate, and then we can put them into our formula, y2 minus y1 over x2 minus x1, and that's what we get. So what I want you to do is think about this pattern here. What's happening as we get this number closer and closer to 2 and this number closer and closer to 1, what happens is this number goes from 2.1 to 2.01, 2.001, 2.0001. So what would you approximate, or what would you guess would be the slope at x equals 1 if you get exactly at 1? What do you think is going to happen? And that's right. If you thought it's going to be 2, you're exactly right. So the slope of the tangent line would be 2. Okay, that's a pretty good approximation, or a good guess. All right. Okay, and so that's all we have to do in number 2. Number 3, use the value in the preceding exercise to find the equation of the tangent line at point P. Graph f of x and the tangent line. So for this one, if I want to find the equation of the line, remember that we can use point slope form. So I'm going to use this point, P12, and I'm going to use the slope here, M2. And so that's going to mean we're going to do point slope form. So it'll be y minus y1. Okay, so here's y1 equals m, which is 2, right, times the quantity of x minus x1. And so then we can distribute. And so we get y minus 2 equals 2x minus 2. And we can add 2 to both sides. And we get y equals 2x plus 0, right? So this is our equation right there. That's a tangent line, right? Okay, and then it says graph f of x and the tangent line. So f of x, this is a quadratic, right? This is a vertical shift by a factor, or by a 1, so it's going to go up 1. So it basically is just a normal parabola starting on the origin, except I'm going to move it up 1, so it starts on positive y-axis. Okay, so it's going to go something like that. So this is f of x. All right, and then now we can graph this function here, y equals 2 of x. So here the y-intercept is 0, right, plus 0. So it's going to cross through right here. And then it has a slope of 2, so it's going to go up 2, 1, 2, and over 1. Oops. So it'll look like that. Okay. All right. And I'll provide some graph paper if it's not there on the Canvas. If it's not there on the Canvas assignment, just let me know and I'll make sure I post it. But yeah, and you're welcome to graph on your own graph paper and or on paper. Just make sure that you pay attention to detail and keep it fairly close, so it's pretty representative of what it should look like. All right, so what we just did there is we approximated a tangent line by finding the secant line as we got kind of closer and closer to x, and subsequently closer and closer to y, right? And then we found the slope, and we saw a pattern in the slope that was getting closer and closer to 2, right? So so as x approaches 1, the slope approaches 2, right?